Here we go.
We are group one. Stephanie, Michaela, Emilia, Maya, and Magdalena. So general overview of the project. We started off by dropping a pumpkin and a coffee filter at the same time from the height of about 1.8 meters, and the pumpkin was 27.80 grams. And the single coffee filter was 0.78 grams. We dropped the pumpkin in a stack of coffee filters. The 7 coffee filters were about 4.80 grams. We wanted to have different masses for the coffee filter, but to keep it less than the mass of the pumpkin so that we could compare it to the time of the pumpkin touching the floor. Why we wanted to do the projects? I am going to start by stating Galileo's law of free fall, which states that in the absence of air resistance, all bodies fall with the same acceleration independent of their mass. And so with this project, we wanted to show how when air resistance is present, two objects will not land at the same time. And this project allowed us to observe the difference in mass on an object and free fall by comparing a control, which was a pumpkin, and to an object and a varied one, which was tested at a heavier mass.
So as we studied in lecture class, we learned that Aristotle stated that objects fall with velocities proportional to their weights. However, Galileo stated and concluded that motion under the action of gravity has constant acceleration. So the magnitude of a uniform acceleration in free fall is independent of the weight of the object, and the constant acceleration is defined as 9.8 meters per second squared. So it is said that if objects have equal acceleration during free fall, if we drop two objects from side to side, they would reach ground at the same time. This would be true if air resistance was not present. And here in our first trial, we have two objects of two different masses, a pumpkin stress ball of 27.80 grams and a singular coffee liner of 0.68 grams. The total amount of time that it took for both objects to reach the ground was 2.5 seconds. The pumpkin ball reaching the ground at 0.7 seconds with an acceleration of 8.8 meters per second squared, while the coffee filter landed at the ground within 2.5 seconds with an acceleration of 0.02 meters per second squared. So because of air resistance, both of the objects did not fall at the ground at the same time.
Next, we added 6 more coffee filters to see if it would change the amount of time to reach the ground. The weight of the pumpkin was 27.8 grams, while the small stack of 7 coffee filters weighed 4.8 grams. As we have said, in the first trial, it took 2.5 seconds for the 1 coffee filter paper to reach the ground, while it only took the pumpkin 0.7 seconds. Once we added more coffee filter papers, the pumpkin still only took 0.7 seconds to reach the ground, while the pieces of coffee filter paper took substantially less time than before and only took 1.2 seconds to reach the ground. The acceleration for the pumpkin in the second trial was 7.43 meters per second squared, while the acceleration of the 7 coffee filters was 0.9059 meters per second squared.
Okay, so the math for the trials we did, we used Stokes' law, which is FD, that is essentially air drop. And that is minus 6 pi times 1.8 times 10 to the negative 5 times the radius times the velocity. And for the pumpkin, the air drag was negative 1.03 times 10 to the negative 2. For the single coffee paper, it was negative 4.4 times 10 to the negative 5. And finally, for the 7 coffee filters, it was 2.20 times 10 to the negative 3.
So the objects, when dropped from the same height, should fall at the same rate as everything on Earth, when in free fall, will experience the acceleration of 9.8, and both of our objects were able to reach their terminal velocity. But as we saw, the two objects did not fall at the same rate of 9.8, as the pumpkin fell faster than the coffee filters. And to readdress what we wanted to see was the effect of mass and air drag in free fall and on terminal velocity. With air drag, the two objects did not fall at the same time. By adding more coffee filters so that there was more mass, they had a higher acceleration, and terminal velocity was reached sooner based on the calculations with the 7 coffee filters.